Hey everyone, I just want to talk about a real quick use case and feature in Talos that not a lot of people know about. And it's this notion of a Talos config as a kernel parameter. The Talos config can be embedded as part of the kernel parameters, but there's a limit on how long a kernel parameter can be. It can only be so long. We can't put all of the data there. So what it also supports is something called the HTTP endpoints. And I want to show you how you could use that for onboarding devices, let's say IoT devices from around the world. So let's start and find the feature in the docs. And it's part of Talos here. And if we scroll all the way down here to the reference, we're going to find the kernel. And part of these kernel arguments, there's going to be a talos.config. And I'm doing it the hard way without the side here. Here we go, Talos config. This is something that's, again, you can send it directly some information, Talos config early. We have ways of embedding that, but what we actually want to do here is set a endpoint. And so we can have a URL that when Talos starts, it's going to try to fetch this configuration. Once network is available, it's going to go reach out and fetch this endpoint and send it some variables like hostname, MAC address, serial number if available, and UUID. So you can use that as a way to match devices and send them a config or a partial config. You can also provide authentication. So if you have an OAuth endpoint, you can actually give some of this config to Talos, burn it into a disk, maybe send a bunch of generic nodes across the world and have Talos pre-installed on them, and then let them go fetch their config later because you don't necessarily know what customer has it or what region it's in if you need to route it in certain areas. So I'm going to show you a full walkthrough on how this might work with an example. To start, I'm just going to make myself a custom Talos image that has this information baked in. So I'm going to head over to the image factory. I'm going to say bare metal machine. We're going to go next, choose our version, AMD 64. Let's not do any system extensions here. This is where we need to customize it. This is the kernel arguments. And in my case, I have a domain setup that is only accessible in my local network, but I'm going to send just the defaults here of variables. You can also customize these variables. These are just some that are fairly common. And so I have a URL for config, just in jgar.net, and it's going to be port 8080. Look for the metadata. So we'll go ahead and create this installation media. And instead of downloading this and booting it up on machine, I do have a physical machine here next to me so I can verify this. I'm just going to copy out the schematic. And then I'm going to go over here to a tool we have called Booter. If you haven't seen Booter yet, we have another video. We can link to it somewhere. And so I'm going to use Booter, which is going to pixie boot on my network. But again, burn this into your device itself, get it on the device somehow, ship it out around the world. And all this is doing is saying, hey, when a machine pixie boots, go get the pixie endpoint from the image factory. And if you want to do that manually for some reason, here's the pixie endpoint itself, which is basically the same thing with pixie on the front. And you'll see here, it's just providing the script. It has that config baked in here, and then we get our initramfs. So we get the general stuff you would need for pixie booting. So I'm running Booter over here. I am going to start that machine now. And in just a second, we'll see it come in to the Booter logs. I'm going to also switch over here to a KVM that I have plugged into that device because we can just watch it pixie boot as well. Now the application I'm going to use for the remote configuration is just a demo application. It just has a GitHub. It's not really meant for production or anything. This was something to show how this could work. And the way it works is it runs a web server and it looks in a data directory, and then it tries to filter out those variables that it gets sent. And so it just says, oh, if you have a variable that matches a file, any file, YAML file in this directory, I will send that back to you. And so we can test this real fast. My machine's still booting up. There it is. It booted, and we'll see it actually once the network is available, immediately right there in the, it scrolled real fast, but it showed it was reaching out for config. Server's not running yet. It's okay. It's going to keep retrying, and you can also see those variables it's sending for the MAC address. It doesn't have a host name, doesn't have a serial, but does have a UUID and a MAC address. So let's run the other server and check it out. Now let's run the web server to send configuration back to the device. So I'm just using the standard config from the register, from the repo, from the README, and we're just mounting a local data folder into this app data read only, and then we're going to put our configuration files in there. So let's go ahead and run that. As the other machine here is fetching config, it does back off for a little while, so it takes longer and longer each time. We'll see the logs come in here, but we can test it before that actually happens. So let's go ahead and generate a config. And this is just standard, Talos config stuff. And then let's move that config into a directory that we want it to be in. So we'll just move control plane into data h as one of the variables, and we'll say it's called this.yaml. And so now I have a file in data h this. If I curl the endpoint for h equals this, I should get that config file back. And I do. I can see the whole config just renders out. It's just the text file gets sent back to me. Perfect. So how do we use this to onboard machines? You can send the full config to them, or you can also send partial config. And one of the best ways to do that is with Omni. So if you're using Omni, you can go over here on the machine, on the main homepage, and you can download your machine config, your join config over here. And this just has your partial config for the node to run and connect to Omni. So if I go over to machines, I don't have that box in this account. And like I said from the documentation, you also could secure that endpoint with OAuth. And so if the node is trying to reach out and get the configuration but requires authentication, it will print a QR code at the console. So it would say, oh, hey, I need you to actually authenticate me to this endpoint. So there is a flow and ability to do that, but you do need a screen installed for that complete cycle, because that's where the QR code kind of gets shown. So it assumes that you're owning the device. Okay, so there's another request from that box. Let's just take the UUID and make it a file. So what I'm actually going to do here is I'm going to copy that download machine config that I got from Omni, which has the partial join config, and we're just going to go ahead and put that into, actually first I need to make a directory. Data u, because that's the variable. We're going to go data u, and then this is the name of it, .yaml, and it has the variable in there. Let's take that out. There we go. So that's going to match whenever this machine fetches again, it should get this join config directly to join Omni. Let's go back into Omni. Let's watch it from the console for a second. Because and again, it does do that back off, so it's not going to be constantly trying, like it's not hammering the the endpoints. It's going to wait a couple minutes to actually get there, but once it does, it'll load that config just like we send it to the API directly. So if we would send Talos control apply, it's doing the same thing here. And there it goes. Immediately it notices that it should have a Sodero link here in the corner, and it's going to start doing that connection. It's going to set up the WireGuard endpoint to connect to Omni, and it's going to do everything else that it normally would do, like I said, if you booted it from the installation media. So here's the device. It already came in, and then from here, we can make it a cluster. There is one thing you usually need to be aware of when making a device, that, especially one that's been sitting on a shelf for maybe 6 months, 8 months, a year, you don't know. The initial install needs to match at least the minor version of what it's booting from, because the API does change version to version. And when Omni is sending a config, right now you have to match it. So if I look down here at that device, I see it has Talos 112.5 installed. So I'm going to go ahead and do 112.5 as well. Again, I can do any of the 112s. We're just going to stick with whatever version is available. So we'll say control plane, give it an install path, and create cluster. We'll go back to the node, and we already see that it has the control plane details. It already got a full machine config sent to it. While it's going through the install phase, I also want to show you something else that maybe doesn't work the way people might think, or only works for certain use cases. And so if I go back over to my machines and I look at that machine, over here, I can update the kernel args. And so these are the kernel args that the machine came with. And usually for a machine, if we boot it off of media built by Omni, we have the Sodero link join config built into those kernel args. And that's how the machine always connects back into Omni. Whenever the state partition is wiped, the kernel args are persistent. So in our case, we have the join config to fetch the config from my endpoint every time it's wiped. So if the state does go away, if the device loses information on what should be installed, it's going to fall back into this, hey, I need to be configured method. All right, so this cluster is fully up and running. The node's all healthy over here. We got everything in Kubernetes applied. And at this point, if I go ahead and if I reboot this node, it's just going to come back and join this cluster. But what happens if I destroy this cluster? Let's say we're going to wipe the whole machine. And again, this wipes the state partition and ephemeral. And in this case, we'll actually see it. Let me go back over here. We should see it come back over to this config. Or we'll see it come back to this config server and try to fetch information again and kind of go through the flow. But let me go ahead and remove that file just so whenever it does come back, it doesn't automatically connect to Omni, because that's what it would do. It would get that config and then say, oh, I need to join said arrow link. So we'll delete the cluster. The machine is going to stay here, even though it's not going to automatically connect in this case, because Omni doesn't make any assumptions about the machines that you have in your environment. If this is a bare metal machine and maybe it's just offline for a while, maybe you're moving locations, maybe it's doing something, Omni's not going to assume it's unhealthy. It just knows it's disconnected. So it'll keep it around and you would have to manually clean that up. And that's it. It's just a really simple HTTP endpoint that you can send config to Talos directly to the API like you would with Talos Control or with a metadata endpoint, no cloud, all of that stuff. It all does essentially the same thing. And so the Talos config variable is something really powerful that's not often used for folks because it's not a well-known thing. So we just wanted to throw this video together, show you how it would work, especially for devices that are either pre-flashed or you want to route them, like I said, regions, or set them up in a certain way, or do some backend configuration so that API could call out, look at the serial number, a user authenticates with their phone based on scanning a QR code, and then accepts that device, it goes into their account. Like that flow is available to you with just vanilla Talos. So it can sit there and be available, and then you can do other things with it. Just send the config. Thanks everyone for watching, and we'll talk to you again soon.